Hello, this is Glenn Yancey, and I will be conducting part 2 of our 4-part series. Part 2's video focuses on Wonderware InTouch licensing and architecture. The objective of this video, as well as all the videos in this series, is to make the complex simple with regards to in-source and Wonderware licensing. The goal of this video is to know how to license InTouch-based architectures. This video is broken up into 3 parts. The first part is on concepts, a refresh of exactly what is InTouch, what's a tag, what's Window Maker, what's Window Viewer, how do we communicate to a PLC. Then we get into licensing. We're going to discuss the difference between the Wonderware Suite versus Orchestra.lic license. Then we're going to discuss all the different breakpoints that we have for our licenses and the different types of licenses, such as development versus runtime, read-only licenses, and InTouch for system platform. The last part of this video is going to focus on architecture. What are the different roles that we have inside of an InTouch architecture? What's the difference between a managed classic versus a managed orchestra application? Also, what's the difference between a thick client versus a thin client, with some focus on the ACP Thin Manager software? Let us reacquaint ourselves with some of the concepts that make up InTouch. What is InTouch? InTouch is the human-machine interface made by Wonderware. In other words, it's the operator interface that operators and others use for supervisory control and data acquisition, also known as SCADA. In essence, InTouch is used on the plant floor as a presentation layer to visualize what is happening in the plant floor process. Well, what is Window Maker? Window Maker is the development environment for our InTouch application. It is where we make our windows. It's where we create our tags. It's where we define the alarms and scripts. Window Viewer is the compiled version of our application or our project. It is where we view the windows. So it is our runtime environment. Inside of our InTouch screens, we create graphics. Graphics represent tags. In other words, they animate based on when a real-world value changes state, whether or not it's analog or discrete. When we represent a specific piece of equipment, we have to use a data type to define our tags. A tag could be temperature, a flow rate, tank levels, pump status, pump command, pressure. So we need to know what data type that is going to be. The first data type is called discrete. Some others may call it Boolean, but it represents a 2-state process. Either something is true, something is false, value is 0, value is 1. So it could represent a valve being open, a pump running. An integer represents a whole number. We see this for counters, lot numbers, and positions. The next data type is called real. Others may know it as float. It represents fractions or decimals. We would use real to represent temperature, flow rates, tank levels with precision. And the last data type is called message. Others may know it as string. It represents alphanumeric characters. So anything that has a letter or other types of characters could be represented as a message tag. Message tag could be production stage, equipment state, product name, an engineering unit. These tag types have categories. Those categories determine where does the value come from. The first category is called memory. So we can have memory tags that are discrete, integer, real, or message. Memory means that the value resides on the computer. It does not come from an external source like a PLC. The next category is called I/O. I/O means that the value comes from a PLC or an external device. We're going to see I/O in a little bit with regards to what is necessary when we set up an I/O tag. So we can have I/O discretes, I/O integers, I/O reals, and I/O message tags. The next category is called indirect. Think of indirect as a placeholder. One tag can be the placeholder to represent different tags upon assignment. So on the InTouch screen, I may have a text box assigned with an indirect tag. That text box with the indirect tag could show me the flow rate from a flow meter in my north plant, and then immediately switch to a flow meter in the south plant. One tag representing multiple tags upon assignment. For our I/O tags, InTouch cannot communicate to a PLC without a driver in place, much like your computer cannot communicate with a printer or a copier without having a driver. For example, an HP LaserJet needs a driver with those specific models and makes. Wonderware provides drivers to do the same, but in this case for us to communicate to a PLC. So the drivers for Allen Bradley based PLCs, Siemens, Schneider, GE, Omron, with more drivers to be released in the next few quarters. So what is necessary for I/O communication? Well, as we mentioned before, we need a driver. That's absolutely necessary. But what if Wonderware does not provide a driver? What can we use to communicate to a PLC? We partner with a company called Software Toolbox. They provide drivers for Wonderware that speak the Wonderware protocol called SweetLink. Their series of drivers is called Top Server, and it is an additional purchase. Example, we may have a customer that needs to communicate to their HVAC systems to control the environment, such as how warm or cool it is inside, as well as the humidity levels. That requires a driver that communicates using the BACnet protocol. Software Toolbox creates a driver that speaks BACnet. So for every I/O tag that we define inside of the Galaxy, each I/O tag requires a concept called an access name, as well as something called an item. An access name is a global grouping that many tags can share. It specifies or answers 3 questions. The first question is, where will my driver reside? The second question is, what is the driver that I'm going to use? And the third question is, what is the grouping defined in that driver to represent my PLC? These concepts are called node name, application, and topic. We need to answer these 3 questions in the access name. Access names, by the way, can also point to a secondary location for I/O redundancy. We see at the bottom on the right a checkbox called Enable Secondary Source. A few other things that we define in an access name for an InTouch I/O tag is the protocol. What type of protocol will it use to communicate to the driver that talks to the PLC? Is it going to use DDE, or Dynamic Data Exchange, which is kind of a dying protocol, or will it use the Wonderware SweetLink protocol? An access name can also use the open source protocol known as OPC, which is a Microsoft standard. There are some drivers that only speak the OPC protocol. InTouch can communicate to those OPC drivers. So access names are global. Hundreds, if not thousands of tags can share one access name. But there is one thing that is unique to each tag, and that is the item. The item is a local memory address in the PLC or a tag in a PLC. Modern PLCs have symbolic tag structures that we can use to mimic the names of our tags to the tag structure in the PLC. So an item is a concept that is local to each I/O tag. Your InTouch application, in order for it to run, needs to be enabled. However, only a license can enable the InTouch application. First off, we have two types of files that when a customer purchases a license from us, they receive a pair of files. One is called the orchestra.lic and the other is called wwsuite.lic. The only difference has to do with the version of the software that you're running. For InTouch, anything older than version 10.5 will require the wwsuite.lic license. Anything newer will require the orchestra.lic license. Now, there are certain version numbers that the client needs to be aware of, whether or not he's running version 11.0, 11.1, 10.5, or 10.6. We have a table at the right that can help determine the actual version of InTouch that you're running. If a customer says they're running version 10.6, that immediately tells us that they're running 2012 R2. Version 11.1, that's 2014 R2. It's important that we do not confuse these numbers with the Microsoft operating system and the version of SQL Server. Here, we have 4 flavors of InTouch for the runtime environment. First is called InTouch Development. Your InTouch development license is part of your development studio. That includes the ability to open up Window Maker, but can also be used to run Window Viewer in order to run your compiled application. The next type is called InTouch Runtime. InTouch Runtime has no development with it. It can only open up Window Viewer. However, there are different tag counts for runtime. 500 tag, 1000, 3000, and then jumping all the way to 60,000. The third type is called read-only. Read-only functions just like a runtime license, but it does not allow an operator to write back to the PLC, nor can he or she acknowledge an alarm. The last type is called InTouch for System Platform. This is when you're using InTouch in conjunction with the System Platform Galaxy. Here, there are no tag counts that we deal with. As we'll see in video 3, all of the I/O tags are part of the Galaxy license, which sits on the server. These licenses, the development, runtime, read-only, and InTouch for System Platform, do come in a remote desktop server edition, or terminal server edition, as it used to be called. Let's go back to the InTouch runtime for a second. On the InTouch runtime, a customer has the option whether or not to buy that with or without I/O. All that this means, the with or without I/O, is whether or not the device integration license can coexist on the same machine as the InTouch runtime license. Having a computer that not only is used for the operator station, but is also used to communicate to the PLC. InTouch runtime without I/O means that we are dependent upon another computer to provide the data from the PLC to us. The device integration license, or as we see here, with I/O, does not mean whether or not an I/O tag can run inside of the InTouch application. It only refers to device integration. As we remember in the previous video, device integration is licensed by node, not by the amount of drivers. Now there is an InTouch development tag with a 64 tag count. We call that the limited. This is the only development license that can be used as both development and a legitimate runtime license. All of the other development licenses are meant to be used for testing purposes when switching between Window Maker and Window Viewer. However, this InTouch 64 tag limited development license can be used for both. Whenever we see tag count, whether or not it's development, runtime, or read-only, those tags are of all tag categories. Any tag that's an I/O tag, a memory tag, or an indirect tag is considered a tag that counts against your license. So let's look at some examples of how an InTouch application can be architected from a very small system and scalable to a larger system. When architecting an InTouch application, we have to know what type of InTouch application it's going to be. Prior to 2014, these were the different InTouch application types. Standalone, which means you develop the application through the InTouch Application Manager. Unfortunately, you could not do any orchestra graphics, which are the vector-based graphics, inside of an InTouch application. In order to do that, you have to do a managed application. Managed can come in 3 different types. A published, which means that you can export the InTouch application that is born in the Galaxy and export it to a standalone type directory. The next is called Managed Classic. Managed Classic is also an application that is born or imported into the Galaxy. However, that application always stays in the confines of the Galaxy. There you can use orchestra-based graphics. And the very last type is called Managed for System Platform, or InTouch for System Platform. This is a truly object-based design where your tags, your alarms, your history, and scripting is handled through the Galaxy. InTouch becomes nothing more than a presentation layer or client for all the happenings inside of the Galaxy. So let's take a trip down memory lane. In the old days of InTouch, going back to 3.1 of Microsoft, InTouch applications were pixel-based. Now, it is true that Wonderware was the first HMI for the Windows platform. However, for a long while, graphics never really evolved. Then we started to roll out newer operating systems, such as Windows 2000, 2003, 2008. That brought about technology that we can use to create vector-based graphics. Vector-based graphics are resolution neutral, so they can incorporate shadings, gradients. When you resize a graphic, the graphic renders smoothly, regardless of the resolution. The problem with this was you had to go through 2 different environments to develop this type of application. You had to work with an object called the InTouch View app inside of the confines of the Galaxy. The IDE stands for the Integrated Development Environment. That is the interface for the Galaxy. InTouch had to be brought into the Galaxy, and then from that point onward, you could use these vector-based graphics. But you had to constantly switch back and forth between these 2 environments. So in 2014, R2, we now have the concept of the modern InTouch application. One interface for pixel and vector-based graphics. Here, you do not explicitly create a Galaxy. In fact, behind the scenes, a Galaxy does get created, but you never really interact with it through the IDE. Everything is brought in through the Window Maker interface. So there's some misconceptions out there. Some people think that orchestra graphics, it's not InTouch content. Well, how else are you going to view it? Orchestra graphics can only be viewed inside of InTouch and the information server as well. A modern InTouch application does not require any additional license. An InTouch license can enable a modern InTouch application. The rumors that our competition is spreading is that Wonderware is not investing in InTouch anymore, and that's definitely not true. Wonderware is still investing in InTouch, but they are bringing in new ways to leverage orchestra graphics, as well as the benefits that it brings. So let's go back to the application types. First is called standalone. Within an architecture, we have a development station, which is on the right, and 3 runtime stations, which are on the left, all on a network communicating to the PLC. In this example, the InTouch application on each one of the machines on the left that say InTouch Runtime with Device Integration means that the runtime environment and the device integration driver, known as the DA server, coexist on these machines. This is where you want to have your price book open so that we can see the part numbers that make up these runtime machines. We need a development studio to create our windows, and we need a runtime license to compile them. On the right, on the development license, it does have the ability to switch between our development and runtime environments, but only for testing. The only exception to this is if we're using the 64 tag limited development studio license, which states that we can use that for runtime in a production environment. This example is a runtime without I/O. Have the same development station on the right, 4 InTouch runtime stations up at the top without device integration. This means that the driver does not reside on these computers. I've designated 2 other computers in here to be my device integration servers. There's a misconception when somebody says a DA server. A DA server is not a physical machine. DA server is just our terminology for a Wonderware driver that communicates to the PLC. However, in this example, we've separated the driver from the InTouch runtime machine onto their own separate machines. In the event that my InTouch runtime applications up at the top cannot connect to get information from the PLCs through device integration server on the left, it will revert to the device integration backup that's on the right. This is I/O redundancy. This is managed through the concept of the access name that we saw a little earlier, where we can define a primary and a secondary machine for device integration. Here are the part numbers. I need a part for development. I need 4 runtime without I/O. And the only reason why it says 60,000 tags at the top is because this application, in my example, is a large application. It's definitely larger than 3,000 tags. But what we should not forget is these 2 machines that are designated for device integration. They will require their own device integration server license. Now let's go into a managed application. A managed means that we have to have a Galaxy to manage our InTouch applications. However, we do not need to purchase a System Platform Galaxy license to accomplish this. Our development studio brings the capability to create a Galaxy and utilize it for pushing out modifications from one machine to another. In a managed environment, we need to understand the concept of a platform. It's really just a software representation of a computer within a Galaxy. So you may hear me refer to a computer as a platform. However, do not confuse system platform with the word platform. System platform is a suite of products, including application server, historian, and information server. Platform just represents a node or a computer. Now, what is a Galaxy? The Galaxy is going to be our application. Now, it is a database, so it does require a database server to be installed. Thankfully, the installation process does this for us without us ever having to interact with the SQL server installation. So it will be the mechanism that we will use to push out modifications from an InTouch application from a Galaxy repository, a single computer where our configuration is kept, out to client operator stations. We call that the visualization node. So let's go over these roles. It's important to understand them when we're architecting a managed Galaxy strictly for InTouch use. So the first machine, the Galaxy repository, this is where the database resides, or our application. It does require Microsoft SQL Server. However, as I mentioned before, you do not have to interact with the installation. It does it for you automatically. Now here it does say server-based only, but that's really only for a full-blown system platform style of Galaxy. For an InTouch Galaxy, it's okay to run this on a Windows 7 or Windows 8 machine. The next is called the engineering station. In many cases, this engineering station and the Galaxy repository are one and the same, but they can be separated. An engineering station can differ from the Galaxy repository for remote access. So hypothetically, you could be a developer and you want to develop the application from the comfort of your own desk, rather than walking down into a server room, pulling out the keyboard, and doing the modifications on the Galaxy itself. Using the IDE remotely allows me to develop an application without physically being on the Galaxy repository itself. However, it can be combined with the Galaxy repository. In other words, one and the same. The last one's called the visualization node, or your InTouch node. It can be server-based, which is a must if you're using terminal services or remote desktop services, or it can be a non-server based. So your operator stations, your industrial panels, can run Windows 7 or Windows 8. This is a computer where InTouch will be displayed, again requiring a platform. What makes this one special is inside of the Galaxy, there's an object called the View Engine. That determines whether or not a platform is going to be a visualization node or not. And multiple InTouch applications can be managed through one Galaxy and pushed out or deployed to multiple computers. So one computer can receive an application from the Galaxy for a water application and for a wastewater application. However, I cannot view them both at the same time unless I'm using terminal services and ACP. In this architecture, I'm going to combine it up a little bit. I have a Galaxy repository. This Galaxy repository deploys an application out to my 4 computers at the top. I have 2 InTouch runtime with device integration, and then 2 InTouch runtime without device integration. So if I'm a developer, I'm definitely going to need a development studio. If I am on my laptop, I connect into the Galaxy repository, work on an InTouch application, adding screens, adding additional tags, and then deploy that out to those 4 computers. What makes this special is the computers that are on the left, the InTouch runtime with device integration, means that that's where our drivers will reside and be used by the 2 computers on the right that say InTouch runtime without device integration. Here in this example, there is no Galaxy license required. Our development license allows us to pursue this route. Here are the part numbers for runtime with I/O and runtime without I/O. Next is remote desktop architecture, also known as terminal services. This means we have to set up a terminal server, a server-based operating system, and enable this remote desktop services environment. Now this can be a little tricky, but bear with me. When you purchase a terminal server license, you have to identify what's going to be the experience for the operator. Are they accessing this through remote desktop client, which in other words are on a PC or tablet? Are they accessing it through a thin client? Think of it like a dummy terminal. Or are they sitting on the console session on the terminal server? So just to make it quick, when you purchase a license for however many clients that will be accessing your terminal server, or remote desktop server, we need to have a session count for how many sessions. They will purchase the first part number with the part number that includes a T. That represents the software license. The next one, for any additional clients, we will purchase a part number that ends with TP. That's a paper license. But when the customer receives the software, it all gets rolled into one software license that specifies the session count for however many users will be connecting into the terminal server. There is a concept here called a Microsoft CAL. A CAL license or client access license must be purchased separately from Microsoft for every user that is going to be accessing the terminal server. So here's an example of a terminal server or remote desktop server environment. I have a Galaxy repository / engineering development station. In this example, I've combined them both. I have a historian server sitting out here, which we're not going to get too deep into the historian server in this video series. I just wanted to show where it would reside. I have 6 thin clients up at the top that are dummy terminals. These dummy terminals check in with a terminal server guided by a program called ACP Thin Manager. In this example, I have two remote desktop servers. One is a primary and one is a backup, or I can have them both as a primary for load balancing. So what do I need as far as part numbers are concerned? For my terminal server, this is where I mentioned before, I have a part number that ends with a T. In this example, however many tags I have in my application, I have to specify at least one RDS or remote desktop server license, and then 5 additional ones for my other clients to make a total of 6. So in this scenario, because I have a backup server, I'm purchasing another set of licenses that end with a TF and a TPF. This is our failover and load balancing license. The price of this is 20% of the terminal server license on the left, because it's not being utilized in this example until a failover occurs. So how does ACP work? A thin client terminal has to be configured to communicate to an ACP Thin Manager server. That server acts as a traffic cop. Once the communication has been established, when the ACP Thin client boots up, it says, "Who am I?" The Thin Manager says, "Okay, I know who you are. You're going to communicate to these 2 terminal servers or remote desktop servers to get your InTouch application. I will define one as your primary and the other as your secondary. In the event that the primary goes down, the secondary or the backup takes over." So in essence, what happens is the thin client says, "Who am I? Which terminal server do I connect to? And if the original terminal server fails, do I point to a backup?" In this example, the answer is yes, I do point to a backup. Now, many examples, the Thin Manager and the remote desktop server are one and the same. I separated them out to show you how the Thin Manager acts as a traffic cop, directing the Thin Manager to communicate to its dedicated terminal server or servers. Also, in a terminal server environment, we have the InTouch Access Anywhere. InTouch Access Anywhere is built on HTML5, but does go through remote desktop services to access a web server with your InTouch application. For specifications that require a web-based rollout for the HMI, the InTouch Access Anywhere will do just that. So this could be sitting on desktops, laptops, tablets, smartphones, smart TVs, and more. As long as you have an HTML5 compliant browser such as Safari, Google Chrome, Internet Explorer, Firefox, and Opera. And there's a variety of others out there that are also HTML compliant. But the browsers that sit on your tablets and your smartphones will be HTML5 compliant. So in this example, I have 5 computers that do not have InTouch installed, but they do have a browser. These computers communicate to my InTouch for System Platform computer that I have listed here and access Window Viewer through an HTML5 experience. However, any computers outside of this network have to access something called a secured gateway. It's what establishes connections for the outside world to communicate in and view the applications that are on my remote desktop server. So here's the part numbers. We have to purchase a license for remote desktop with concurrent licensing to do InTouch Access Anywhere. Now let's talk about version compatibility. Here's an example where I have a computer, I install version 10.1 of InTouch onto that machine. The customer gives me their application, which is version 10.5. Now the license I have on this machine is a 10.1 license. I think if you can remember from a previous slide, this would be my WW Suite license. In this scenario, will this work? The answer is no. That application is 10.5. That means that my software needs to be 10.5 in order to open up that application. Now for my software to be 10.5, I need my license to be 10.5 as well. So now let's go to the next scenario. The software that I have installed on the computer is 10.6. My application is 10.6. However, my license is 10.1. I've yet to put my upgraded license on that machine. Will this work? The answer is no, because my license needs to be the same version as my software in order to enable that software. Scenario number 3. I have 10.6 of my software installed on a computer, 10.6 application that a customer gives me, I put on that computer as well. My license is 11.0. Will this work? Answer is yes, it will. Our license is backward compatible. It will enable an older version of the software so that I can open up my application. Example, have a software version 10.5. Have an application version 10.6. And my license is 10.6. Will this work? The answer is no. Again, my software needs to be the same version as my application in order for me to open up that application. Last example. Software is 10.6. Application 10.5. My license is 11.0. Will this work? Well, it kind of will work. Here's the gotcha though. As soon as I open up that version 10.5 on my 10.6 software, which is enabled by my 11.0 license, that 10.5 application will be forced to migrate. In examples like this, it's good for a developer, specifically a system integrator, to have a variety of virtual images with different versions of their software so that they can develop and test out applications for their customers without having to do a conversion. So thank you very much for attending part 2. Stay tuned for part 3, which is system platform licensing, and part 4, which is our historian licensing, both server and clients, with the information server portal.
Need to learn more about this and other InSource products? Check out our training tracks designed to guide you down your learning path for InSource products. Whether you're using a classic InTouch and historian architecture or using system platform, we have a track to help you get the most out of your software investment. To register or learn more, click the link in the video description below. Thanks for watching this InSource video.